I'm Satya, Assistant Professor, Department of Computer Science from KCS Kasinada College of Arts and Science. Now I am going to give introduction of operating system. What is an operating system? The definition of operating system is it is a program that acts as an intermediary between a user of a computer and the computer hardware. The main goal of the operating system is it execute the user program and solve the problem very easily, and it also make use of the computer system convenient for us to use. The computer hardware also used in an efficient manner. What are the components of the computer system? There are four components in the computer system. That is, first one is the user. There may be so many users, and then the system as well as the application program, compiler, assembler, and the program that are written by the users. All are the application programs, and then the computer hardware are the basic things. Between the computer hardware and the system and application program, the OS is a program that acts as an intermediate, and it conveys the messages between the computer hardware and the system application program. Next step, storage structure. All the details that are stored in the computer only. The computer has two type of memory, main memory as well as the secondary memory. The main memory is very large one, and the CPU can access the memory directly. It is the random access memory and it is a volatile one. And secondary memory means it is an extension of main memory and it's a non-volatile storage capacity. Next, hard disk drives are also the secondary memory. It's divided into tracks, and the tracks are further divided into sectors. The disk controller determines the logical interaction between the device and the computer. It's a non-volatile memory. It's a faster one, and it's various technology, and it's become very popular because of its performance. These are the hierarchy. That is, the registers are very small and it's very fast to access. Likewise, the last one, binary types, is very large and it's very slower in access, and it's divided into three types: primary storage, secondary storage, and tertiary storage. Primary storage means it can access by the CPU. Secondary storage means it's a very non-volatile one and the data can store in the secondary storage. Tertiary storage, we can take over the data wherever we need it. DMA, that is direct memory access structure. That is, the data can be transmitted between the I/O devices in constant speed without the intervention of CPU. That is the DMA. Here, device controller transfer block of data from buffer storage directly to main memory without the CPU intervention. Only one interrupt is generated, that is to inform about the completion, rather than one interrupt is per byte only. There are so many types of operating system. First, we are going to see about the multi-programming, that is a batch system. Here, single user cannot always keep the CPU as well as I/O devices busy. Multi-programming means it stores the data as well as the program as a whole. The CPU can execute only one program at a time. Here, for execute the job scheduling is maintained. When the job has to wait, then the OS switches to the another job for the execution. This is the layout of simple batch operating system. Here, the memory is divided into two types. The one is the basic type, that the OS is stored permanently, and the second is the user program data. Here, the program that is executed and the program to be executed all are stored here. Next, multitasking or time sharing system. The logical extension of that system is the multitasking one. The CPU switches jobs frequently. User can interact with each jobs while it's running. That is interactive. Here the response time means less than 1 second. Response time means the CPU give the first response. That is a response time. The user has at least one program to be executed in memory. That is the process. And CPU scheduling means there may be several programs in the system. Okay, if you want to execute the program one by one, the CPU will schedule the jobs. Next, if process does not fit into the memory, swapping is done there. That is, move the process from one memory to another memory. Virtual memory allows the execution of process not completely fit into the memory. Next is the cluster system. Like multiprocessor system, multi-systems also work together. Usually sharing storage via storage area network is done here. It is high available service with the services failures. Here there are two types, asymmetric clustering, symmetric clustering. Asymmetric means the machine is hand standby mode. Symmetric means it has multiple nodes and monitoring each other. Some clusters are for the high performance computing. Applications must be written to use parallelization. Some also having distributed load manager to avoid the conflicting operation. This is the cluster system. The computers are interconnected together and they are having the same location for storing the data. Next is time sharing system. Time sharing system is also one of the logical instances in which a CPU switches the jobs. So frequently the users can interact with each jobs while it is running, creating interactive computing. Here also the response time is less than 1. Here the CPU scheduling is done, swapping also done, and virtual memory is used for if the process is very large when compared with the primary memory. Process means there may be so many programs in our system, but the CPU can execute only one program at a time. That program is known as the process. Real-time system. Here, that is, the application is dedicated for a controlling scientific experimentation, medical, industrial, and that condition we are using the real-time system. It is well defined with a fixed time constraint. There are two types, hard real-time system and soft real-time system. In hard real-time system, we can use the systems in a correct particular time workout. If it is mismatched with the time, then no problem will be occur. In soft real-time system, it's equal to the robotics, industrial controller, what are needed, and it's used in the application for them. That is virtual reality, multimedia, etc. And it's required the advanced operating system feature. And last is the distributed system. Distributed system, so many processors are there, and all are the computation processor distributed over the processor. It is loosely coupled system. Each processor has local memory. Processor only communicated with one another through various communication lines such as high-speed buses and telephone lines. The advantages is resource sharing, computation speed up, reliability, and communication. Next to distributed system. Distributed system continuation, that is network operating system and distributed operating system. In network, we are using file sharing, communication scheme, and run independently from other computers on the network. Then distributed operating system means it is less autonomy between the computers, gives the impression there is a single operating system controlling the network. Thank you.